As a disclaimer, this video assumes that you have knowledge of basic fractions and conversions of fractions into equivalent fractions. Please click one of the following links if you do not understand these concepts. Let's say that your friend challenges you to a game of rock, paper, scissors and bets you $50. Now, wouldn't you want to know your chances of winning? To determine this, we use something in math that we call probability. Now, what is probability? We define it as the extent to which an occurrence is likely. We call things likely, unlikely, very likely, rare. These are some of the terms that you might have heard in previous years. We can use something called a tree diagram to help us determine the probability of winning. We can also use it to help us determine the probability of losing or tying. Let's go ahead and map out all the different paths on the tree. We like to call these occurrences. For example, in a game of rock, paper, scissors, you can roll rock, or you can choose rock, and your opponent could choose paper. And that's one path, or one occurrence. In total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 occurrences. How many of these are wins? Let's count. We have 1, 2, 3. That's 3 wins. How many losses? We have 1, 2, 3 losses. How many ties? As you might have guessed, we will have 1, 2, 3 ties. This makes sense because there are 9 total outcomes and 3 wins, 3 losses, and 3 ties. 3 plus 3 plus 3 is 9. Let's go ahead and determine the probability of winning. We describe the probability of an occurrence as the number of times the occurrence happens, or the frequency of the occurrence, divided by the total number of occurrences. So, for the probability of winning, we know that we've won 3 times. So we put a 3 in the numerator. And we know that the total number of occurrences is 9. So the probability of winning is 3 over 9. Also notice that out of all the total possible outcomes, we lose 3 times. So the probability of losing is going to be 3 divided by the total number of occurrences, which is also 9. The total number of occurrences is not going to change, no matter what. And finally, as you might guess, the probability of tying is going to be 3, because out of all the events we've tied 3 times, over 9, because 9 is the total number of occurrences. One interesting thing with equivalent fractions is that we can write this as 1 over 3. We just divided the numerator and denominator by 3 to get 1/3. And we can do the same for this 3 over 9 and this 3 over 9. So overall, in a game of rock, paper, scissors, we've determined that you have a 1 in 3 chance of winning, a 1 in 3 chance of losing, and a 1 in 3 chance of tying. Now this is theoretical. Let's compare it to a real result. To test the theory, I played a game of rock, paper, scissors 25 times with an opponent. So that's 25 total outcomes. I won 10 times, I lost 5 times, and I tied 10 times. So experimentally, I won 10 out of 25 times. But this is not equivalent to the probability that we calculated theoretically. However, this discrepancy is expected with a small number of trials. I will show you in the next video how running, for example, 2,000 trials will result in a closer match. Until then, thanks for watching.